We're going to heat treat some metal today. This is the first time I've ever done this, so God only knows how it'll turn out. But anyway, these are the knife blanks that I'm going to treat. I'm going to try and raise the temperature, and I'm going to use American terms because I've only ever watched YouTube. I'm going to try and raise the temperature of this metal, which is 1095 high carbon steel, to around 1450 to 1480 degrees Fahrenheit, at which point the metal itself will lose magnetism, which means it will become incredibly hard, but it will also become incredibly brittle. So following heat treatment, I then have to go into a tempering process, which is at a much lower temperature, around 400 degrees Fahrenheit, and for a period of 2-3 hours. So that can be done in a standard oven. But as for this little setup here, it's an old wood stroke charcoal barbecue that's been sitting around since Adam was a boy, and I've decided, well, hey, why not use the bloody thing? So we've got the wife's hairdryer and some tin flashing connecting it to a bit of an old aluminium pool wand, and some more flashing, and then into a piece of galvanised water pipe. Now, all the good books say that I shouldn't be using galvanised pipe, but Bunnings didn't have anything else. The only reason you shouldn't use galvanised water pipe is the zinc will burn off and it gives off toxic fumes. So we'll just have to make sure that we don't go sticking our conch over the bloody thing and inhaling all the toxic fumes. So that's where I'll leave it for now. I'm about to put the charcoal in, which you can see over there. Apparently you've got to use charcoal, you can't use briquettes. Only genuine charcoal will burn hot enough. Briquettes don't get hot enough, apparently. And yeah, we'll see what... Righto, the fire's lit and we've just got to wait for it to come up to temp now. Just for a little bit of useless information, don't buy these bloody redheads fire starter bullshit. They're useless. Okay, fire seems to have caught. So just wanted to show you quickly why I need the hairdryer. I'm feeding air into the thing right now through that metal pipe in the bottom, and you can see that the air really excites the flame. That's where I'm going to get my 800 degrees Celsius from. So we'll just let it catch a bit more. I need a small bed of heat in there. Okay, the fire's going, and we might say she's roaring away. And you'll notice in there, just on the right hand side of the fire, the handle of the first blade. Not terribly worried about getting the handle heat treated, but I do want the blade to be treated. So the blade itself is in there, and it's heating up really nicely just at the moment. You can see the benefit of pumping air into the fire. Okay, we're going to pull the knife out and have a look. See whether she's up to temp. Yep, she's up to temp all right. She melted. Well, that's a goddamn shame, isn't it? Oh well, there you are. I've learned something today. So, anyway. Well, that's a pity because that was the high carbon steel knife. These other two are mild steel, which apparently can be heat treated, but clearly without the high carbon content, you're going to have to be really careful. As you can see, the blowing air into the fire really does chew the charcoal too. So anyway, I'm learning. Okay, there's our little experiment over with. Both of the mild steel blades worked. I got them both to cherry red temperature. Unfortunately, this poor specimen, can't quite get the focus, but unfortunately this poor specimen got way beyond the temperature I wanted and melted. So you can see how hot force-blown charcoal can get. Little wonder blacksmiths actually use it, but yeah. So anyway, the two mild steel blades heated nicely, got them to just an orange red, I guess, just a little bit beyond cherry red, and they'd lost their magnetism because I checked it with this little magnet. You just tap the magnet along the metal itself, and if you don't feel any adhesion, then you've reached the right temp. So yeah, so there we go. I'll let the two other blades cool in that little tin of metal you can see down the bottom right, and they did flash, but not dangerously, so that's good. Yeah, that's about it. Interesting experiment. Just a little bit of a postscript, and we've gone back to the phone just briefly. That's the high carbon steel blade, the 1095 high carbon steel blade that got left in the furnace a little bit too long. As you can see, she well and truly melted. Well and truly. You can see the bubbling. You can see where the metal's actually flowed. There's little lumps of metal on there. Yeah, not a real good experiment as far as this particular piece of work is concerned, but hey, I've learned a lot from this. One thing being that I don't need a whole lot of air going into the bottom of the charcoal. Just enough to get the stuff up to the proper temp. Then whip it out, check it with the magnet a couple of times as you go, and when it's lost magnetism, plunge it into the oil. And yeah, that was the easiest part, plunging it into the oil. I was worried about flash point and flames and the whole tin going up, but no, it doesn't happen. Doesn't happen. The metal cools very quickly. The oil absorbs all the heat. So yeah, like as I said, interesting experiment. And okay, a bit of a postscript. The two mild steel blades are in the oven right at this point in time, being tempered. This is the high carbon steel blade, the one that I really wanted to work, but basically, let's be honest, I fucked it up. You can see I hit it with an angle grinder up in the shed, and I'll just try and get a bit of light on the thing. There we go. You can see there that the metal has indeed melted and flowed. So, yep, okay, learned a lot. That was a valuable experiment, a really, really valuable experiment. And according to all the stuff I've seen about making knives and experimenting with this sort of stuff, this is what happens when you don't know what you're doing and you're learning on the go. And that's basically what I'm doing. I'm learning on the go. The two mild steel blades are currently in the oven. They've been in there for about an hour and a half now. They'll probably be in there for another hour and a half. I've got them set at 200 degrees C, so yeah, we'll let them go. Their surface is good. You can test the surface, you can test the hardness by running a file across the surface, just the corner of a file, and if they scratch, then they're not quite hard enough. If the file skates across the surface, then they're hard enough. And the file did actually skate across the surface on these two, so I'm pleased with that. We'll just see how it transpires.